Hello and welcome to another Pre-Calc 20 Math Extravaganza. Today we're going to be doing some investigating of the sine law, which you are all at least vaguely familiar with. So we're just going to do a little review, a little warm-up from the previous stuff that we've been working on. So I want you to go ahead and hit pause, work through these, do them as quickly as you can, and the answers will be here for you when you get back. So go ahead and hit pause now. Okay, so there's the answer to those four. Hit pause, take a look at them. Hopefully you were able to work those out. I want you to read the focus on. So these are some of the things we're going to be focusing on. You can hit pause and read those. Today we are going to basically be looking at this one and this and this and this. So that's about all we're doing today, and then in the next couple lessons we'll focus a little more on this and rehash all of those other things as well. Investigate the sine law. Now this investigation is for you to do on your own. You need a ruler and you need a protractor. So hopefully I remembered to lend you one so you could take them home and do this when you watch the video. If I didn't, then you can give me a hard time tomorrow. What are you going to do? Or try to find a ruler and a protractor at home to go through this activity. So when you get to the end of this, you should notice that all of the three things above are equal. Okay, so all of those things that you looked at. And that is the sine law. And I will leave this for you to fill out, and you can grab that information from your textbook. So proving the sine law. So the first step to proving the sine law is we start with a triangle. Triangle ABC, simple enough. Now, it asks us to draw an altitude, which is basically a height, from A to D that is perpendicular to B and C. So I've gone ahead and I've made one in advance, and you can choose your point D somewhere between B and C, but D has to be right here because this has to be perpendicular. Okay? If you move it anywhere else, and it also has to attach to A, so if you move it anywhere else, obviously you can still have the point AD, but that is no longer perpendicular. So I've put mine right here to ensure that that is perpendicular. Okay, that's what this little symbol means. Perpendicular to BC. In triangle ABD, sine B equals blank. Isolate H. So sine B, so we are going to call this altitude H. Now sine B, this is angle B. Okay? Sine B. Sine is always opposite over hypotenuse. So in this case, sine B equals H over hypotenuse, which is the arm AB, this arm right here, that's the hypotenuse. In ACD, so ACD, this right triangle here, sine C, so sine of this angle C, equals blank. So sine C, sine is opposite over hypotenuse, so this is H over AC. So here's the secret. Isolate H. Here, H equals AB sine B. Here, H equals AC sine C. That means that since both equations equal H, they equal each other. AC sine C equals AB sine B. Rewrite as partial sine law. Okay, so divide off AC by this side. And basically we have sine C, and then we divide both sides by AB as well. Okay, so here AB will cancel, here AC will cancel, and we're left with sine C over AB equals sine B over AC. Now, when we make this triangle, the side corresponding to the lettered angle is always opposite the triangle. So B, side little b, will be over here, which we labeled as side AC before. C is the big angle, side little c will be opposite. Big A is the angle, side little a will be opposite. So let's take a look at what we've got now. Sine C over AB. Well, AB we just labeled as C. So that then looks like sine C over little c equals sine B, and we just labeled AC, this length over here, as side B. So sine B over B. There is your partial sine law. You could do it again and incorporate A, and you'd find out that they all work out to the exact same ratio of the sine of the angle over the side. So let's try a couple examples here. Find the value of x to 2 decimal places. All right. So let's call this, well, why would we do that? Let's call this x, y, z. Triangle x, y, z. Doesn't matter where y and z go. X has to be here because it's across from the little x. So sine x over x equals sine, now we don't have angle z, so let's use y. So sine y over y. So this is side x, this is side z, this is side y. So sine 117 over little x equals sine 17 over 19.6. Now, since we're solving for x, we might as well just start with it in the numerator so we don't have to worry about moving it to the other side. And this is perfectly acceptable to just flip both of these. But if you flip one, make sure you flip the other. Now, where I've seen mistakes made are people taking the sign of side lengths. You can only take the sign of an angle. So watch that it has a little degree symbol attached to it. Those are the things you're allowed to take the sign of. You cannot take the sign of 19.6 because it is not an angle, it's a length. All right, and then we can go ahead and solve this. So x equals 19.6 times sine 117 divided by sine 17 degrees. So punch it into your calculator here. 19.6 times sine 117 equals, okay, now we want to divide that by the sine of 17, and we get 59.7. So x, your angle, is 59.7 degrees. That one's done. Okay, so now the next one, again, we want to solve for x. This one we have to call x. We could call this y and this z, which means, again, we have big Y and little y. So x over sine 38.4 degrees. Again, we know we can take the sign of this because it has a little degree symbol. Equals y, which is 27.69 over sine 78.2. Go ahead and solve for x by multiplying both sides by sine 38.4. So x equals 27.69 times sine 38.4 degrees, all divided by sine of 78.2 degrees. And you can go ahead and solve that, and when you come back, the solution will be ready for you. So here's your answer, x equals 17.6. And we're done. Okay. So now we're going to work on finding the missing angle instead of finding the missing side. So here we have little x, we don't have big X, but we'll call this y and z. And again, we have big Y and little y. So we can go sine of unknown big angle x over 6, its corresponding side, is equal to, now if we have sine of one angle on top, we have to have sine of the other angle on top as well. So sine of 74 over the side length y, which is 11. So we're solving for this, so sine x equals 6 sine 74 degrees divided by 11. Sine x equals, and you can hit pause and solve for x, which is big X, and when you come back, the answer will be ready for you. So there you have it. Sine x is 0.5243, which means x we get by taking the inverse sine, which gives us 31.6 degrees. This question is exactly the same as this one. There's only one thing I want to point out. I want you to go ahead and try this, but when 11 and 6 are quite far apart in terms of their magnitude, that means our angle x, which is across from 6, should be a lot smaller than the angle y, which is across from 11. So if this is way bigger than this, then this should be quite a bit bigger than this. And we found out that x is 31.6 degrees. So here you can make a reasonable prediction. This one is just a little bit smaller than this one. So this angle that belongs to this side should probably be just a little bit smaller than this angle that belongs to this side or corresponds with that side. So when you find your solution, it should be somewhere in the 70s. So if you had to guess, maybe 73 degrees. That would be my guess. So go ahead and solve for it. See if this estimate was reasonable. So here is a your turn, and I want you to go ahead and try it. And as always, when you return, the answer will be here waiting for you. So go ahead and hit pause now. Okay, welcome back. Here's the solution to the above your turn. I'm very hopeful you were able to work that out and use your 180 rule to work out the value of n. That's it for today. I will see you in class tomorrow.